Alright, this is video number 3 on the Exam 4 review. We're almost done, folks. Let's look at 26. So we talked about when you solve radical equations, there's a couple of things that are a little bit different that you need to do with radical equations. Of course, a radical equation is an equation that has a radical in it. So number 1, you need to isolate the radical before you square both sides. And number 2, you also need to check answers. We found out that you can do everything right and get an answer that doesn't work. By squaring both sides, sometimes you introduce a new answer that doesn't work in the original equation. So let's go ahead and get started. On number 26, the radical is already isolated. Let's go ahead and square both sides. So the easy part is on the left. We get 3x minus 1. Actually, either side here is not too bad. Of course, 7 squared is 49. So this is now a two-step equation. We'll add 1 to both sides. We get 3x equals 50. And then divide by 3. You get 50 thirds. Now check this. We would plug in 50 thirds. 3 times 50 thirds is just 50 minus 1. We're going to get the square root of 49 equals 7. And notice that's true. It does work. Let's check. Alright, let's look at 27. So here's a case where the radical is not isolated. We need to get rid of that minus 4. Notice you cannot, just like we talked about in class, you can't add that 12 and that minus 4 as if the 12 didn't have a... You can't just pretend it's not under the radical. That makes a difference here. So what we're going to want to do here is add 4 to both sides first. And by doing that, we do get the radical by itself. Now notice here, the square root of a number equals negative 3. We've talked about this. You can't take the square root of a number and get a negative. In fact, we know if we take the square root of a negative number, it's not a real number. So in this problem here, there's not going to be a solution. We say no solution. Now let's say you didn't notice that and you squared both sides. You get x plus 12 equals 9. Subtract 12 on both sides, you get x equals negative 3. But if we plug that in, we get square root of negative 3 plus 12, which is 9. The square root of 9, that's 3. 3 minus 4 equals negative 7. That's not true. And so you can see that it's important you check your answers so that if you miss something like this, you'll catch the problem. In this problem, you can actually tell, but when we get to the problems 29 and 30, it's not as clear sometimes, so you got to check all your answers. Alright, let's move on to 28. So 28 is a lot like the one we just did. We need to get rid of that 4 so we can get the radical by itself. So you get the cube root of 2x minus 5 is equal to 2. Now be careful here, this is not a square root, so you don't want to square both sides. The opposite of taking a cube root is cubing both sides. And so that's what I'm going to do here. You're going to get 2x minus 5 equals 8. So this is a two-step equation. We'll add 5 to both sides. And divide by 2, you're going to get 13 over 2. Alright. Now I didn't check that one, but if you check that, you'll see that it does work. Alright. On number 29, we've already got the radical by itself, so I'm just going to go ahead and square both sides. You got to be careful when you do this, though. You got to square the whole side. So notice I put parentheses around the x minus 1, and I squared that. You can't just square the x and the minus 1 individually. It turns out that you get a different answer than what we're going to get here. Remember, you got to square the whole side. That's why we're putting parentheses around it. And actually, this is FOIL in disguise. You're going to have to multiply 2x minus 1s. So when you do that, you get x squared minus x plus 1. Of course, we have minus x and a minus x make minus 2x. And so on the left, we're going to get x squared minus 2x plus 1. Of course, on the right side, we just get 3x plus 1. So this is a quadratic equation. We want to get 0 on one side. So let's see, we need to subtract 3x and 1 on both sides. Notice I like to keep my x squared positive, so that's why I'm getting rid of the 3x and the 1. You're going to get x squared minus 5x. Notice a plus 1 and a minus 1, that's 0. On the right side we get 0. Now be careful here, you're not going to be using the AC method on this one. You got a GCF here. So factor out the x. So let's set each of our factors equal to 0. And we're going to get 0 and 5 here. Now let me check the 0. When you plug that in, you get negative 1 equals square root of 1. And that's not true, that's false. And so the 0 doesn't check. Let's try the 5. So 5 minus 1 equals the square root of 15 plus 1, that's 16. You're going to get 4 equals the square root of 16, and that's true. And so the only correct answer here is the 5. Alright, let's move on to number 30. Now notice we don't have the radical isolated, so we need to add x to both sides. And so now this is just like 29. In fact, you may want to stop the video and see if you can do this one. Doing the exact same thing we just did on the last problem. Alright, so we're going to square both sides. On the left we get 5x plus 21. Again, on the right side, that's a floral in the sky situation. We got to multiply those two x plus 3's. And you get x squared plus 6x plus 9 when you do that. So this is just like 29. Notice we've got a quadratic equation. We need to get 0 on one side, and I'm going to get rid of the 5x and the 21 on the left. So we'll subtract 5x on both sides and also 21. So we're going to get 0 equals x squared, 6x minus 5x is x, and 9 minus 21 is negative 12. So we're almost there. We got definitely need to use the AC method here, 3 terms. This is a trinomial. So we need 2 numbers that multiply to negative 12 and add to 1. That's going to be 3 and 4. And the 3 is the one that should be negative. So notice that's going to work. We can take the shortcut here. And we're going to get 3 and negative 4. And I'll let you verify that the negative 4 doesn't work, but the 3 does.